Welcome to the Scaling Tech Podcast, the podcast for software engineering leaders. I'm Aaron Syme, your host, and I'm excited to bring you a conversation today about prompt engineering with one of the engineers behind GitHub's Copilot, John Berryman. We'll talk about what prompt engineering is and best practices for building LLMs directly into your software applications. He's co-authored an excellent book on the topic, and I'm sure you're going to learn a lot from this conversation. So let's get to my interview with John Berryman on prompt engineering for LLMs.
Welcome to the Scaling Tech Podcast, where we help you manage your growing engineering team. Through expert interviews, we help you navigate the challenges of leading, hiring, growing, and nurturing your tech team to deliver the value your customers demand. Brought to you by agilityfeet.com, experts in staffing engineering teams in Latin America for clients globally.
John Berryman is founder and principal consultant at Arcturus Labs, where he consults on large language model application development and is a specialist in prompt engineering. Prior to that, he was a senior machine learning researcher at GitHub, where he helped to build both the Copilot code completions product and the chat product. Earlier in his career, he built search and recommendation engines and co-wrote the book Relevant Search. His most recent book is published by O'Reilly and is titled Prompt Engineering for LLMs, the Art and Science of Building Large Language Model-Based Applications. Welcome to the Scaling Tech Podcast, John.
Yeah, good to be here. How's it going?
It's going great. Great to have you here. Thanks so much for joining. Really excited to, kind of hear your take on large language models. Been enjoying the book you wrote a lot and learning a lot from it myself personally. So really appreciate the work that you and Albert did in writing that. I want to start with a question though, right in the title is prompt engineering. And I've heard, a few different definitions of that word over the years. So I want to start with how do you define prompt engineering?
To tell you the answer to that, I guess the question is, how do I define prompt engineering today? Because it's also a term that I feel like has been kind of moving over time.
Right.
I think when you think of prompt engineering, the first thing that comes to mind is something like ChatGPT or like even these generative image models, right? You type in something and you get it to generate some sort of output. And that's a big part of it. That is where the name, after all, came from. But when I talk about prompt engineering, really, perhaps it's a bit of a misnomer at this point, but really what I'm getting at is something a bit deeper than that. I'm getting at not only how you converse with these models to get the best behavior out of these models, but also like how you shape the application around it so that you have a good interaction between the user and this alien technology that we've created. How can you solve the problems for the user? So building the whole application, really.
Yeah, I like that definition better myself too. I think it better fits the word engineering in it for one thing. And I know, like in the beginning of the book, you talked about kind of these different levels of sophistication of prompt engineering with that ChatGPT interface where we're just kind of typing a question simplistically, being the most basic form. But as you get more sophisticated, you're building applications that kind of augment the user's prompt with other data or context. I mean, tell us a little bit more about just a high level of how that works.
Well, so I guess we're thinking about like the different levels of complexity, like you might expect with these things, right? Well, the first level, I guess, would be something that is exactly prompt engineering. You're going to type in something, and you're going to get an answer out. This is me in a conversation with ChatGPT. Write me a tutorial to create a React out or something like that. Answer this question, extract this content. But you can, with one request to a language model, you can do a lot of very interesting things. You can summarize things, you can extract data, you can have it, generate, conversational type answers. And so the next level is when you start putting these things in a loop or doing more complex multi-step tasks. And I suspect we'll get into this as we go forward. But what we're kind of getting at the extreme of this is something that people are calling agency. Now, agency is another one of those terms. It's going to be another one of those terms for a while. It's kind of a buzzword, and when everyone says it, they have a different thing in mind. But when I think of agency with the technology we currently have on hand, I'm thinking about something that still is something that is allowing these language models to take multiple steps and do things on the behalf of the user. But at this point, it still very much incorporates the user into the process. So a more complicated type of prompt engineering application, large language model application, would be starting that loop where you move from the user's problem space, which is varied as anything you imagine. Is all these applications we're coming up with, and that first arc of the loop is to convert it into the space that a language model is comfortable with, which is text and more so these days, images and stuff as well. And then you move once the language model makes a completion, then you harvest that information. Hopefully, if you shape the prompt right, it will have the information that you require in it, and you take that and put it back into user space. If you do this over and over again, you've got conversation, right? You've got a conversational API. Or if you do this over and over again and have the agent looking at rules, like here's the steps that you have to follow to get this information, then you've got a kind of what I call workflow agency, where you're going through a set of steps. And then maybe this is just fodder for downstream questions, but there's also offshoots of how this can be more complicated and sophisticated. Where do you get the data from? How do you get, RAG type applications? How do you get this data presented to the model in such a way that it's useful? How do you give these agents access to tooling, something that they, rather than the chattering, they can reach out into the real world and do interesting things in the real world. So,
yeah, that's a really interesting next step evolution in this, and so I definitely do want to explore that more with you. I want to go back in time a little bit first, though, and learn a little bit more about how you became an expert in prompt engineering. Because in particular, when you started with GitHub, you are working in your other area of expertise, area I originally know you from, in enterprise search. How did you make that transition from search engineer to prompt engineering and LLMs? What's the relationship between those two?
I might surprise you to say almost none. It's strange. I'll explain. Most of my career, I like to say, has been fortunate accidents and falling uphill. I like the places I've gone, but much of it hasn't been because I'm particularly crafty and cunning and charting my course. With search technology, for example, I work for Open Source Connections, which we both work for, and Eric just needed the CEO, I guess, of Open Source Connection, just needed someone to get out there, get in front of customers, and so it's like, poof, you're the search expert. But that parlayed itself into a book over time. That was great. Once I had the book, that kind of parlayed itself into a gig at Eventbrite. At first, I built out search and recommendations for them a couple times. That was a foot in the door, obviously, for my work at Copilot, and that's probably a good place to start up, the supposed transition story. At Copilot, my first year and a half was working on the search team, and we built the next generation of search 2 generations ago. So it's now one old, but we built we built search using Elasticsearch. A little bit of relevance work. That's what I was really keen on. We didn't do quite as much as I'd hoped for. And so when that project was wrapping up, there was an opportunity to jump into a different line of work, data science. And so that's something that I'd always wanted the data science merit badge. Got a chance to join that team, and it was good. It was a lot of SQL, a lot of analysis, and a lot of PowerPoint presentations. Basically, that's what data science was. And so after about a year of that, I was like, okay, I'm ready. I've got my merit badge. I'm ready for something else. And then I got the opportunity to join Copilot because I had this data science background at that point. I was deeply an engineer, and they needed somebody to come in, and it wasn't me; it was the team. But it was just finishing up with the research phase of Copilot. They're like, these GPT models are mature enough that you can do some really interesting work. And as the research was wrapping up, I was on that first team that kind of saw it into production. So interestingly, the automatic assumption is, well, okay, with a background in search and completion search and prompt engineering, I was doing RAG applications.
Right.
But really, it was mostly it was a lot of the same feeling work, because you had to collect information, put it into a prompt, and send it to the model in a way that it could generate completions. But it wasn't your stereotypical semantic search or even like lexical search. It was like we were inside VS Code, so we were using language service protocols to look up the method that you were getting ready to type in, other information like that. So anyway, that's kind of my trajectory to this point, and then the rest is history that's being written.
Right. Exactly. Well, you're certainly too humble, I know, about yourself in that, but I mean, you did bring up the concept of RAG, retrieval augmented generation. It is definitely an area where these two, areas of expertise that you have overlap, of prompt engineering and enterprise search and relevancy and that sort of stuff. I guess talk a little bit about how those two worlds intersect, because I think that initially, like in when ChatGPT kind of first came out into the sort of consumer awareness, people talked about it as if this is just a really sophisticated search engine, which is not really correct, right? But there still is overlap between these things in ways that they work together. So talk a little bit about that.
Yeah. So I think RAG is almost a bad way of chunking up the semantic space here. RAG assumes when you say retrieval augmented generation, you assume that you've got this black box that does all of that. But really, it's a very transparent black box. And when you look through it, you see two very, very, very distinct things that you would do well to treat in isolation. You have retrieval and you have generation. And you can almost think about those as just being just different things. Uh, for example, if you have some sort of application, RAG application, that's doing like IT support, and if you're looking at this as if it's an opaque black box, whenever it returns, whenever it gives generations that don't match your expectations, then you don't have anywhere to look to say, oh, this black box is messed up. But if you realize that it's a pipeline that goes from, how do we index the documents? If you're doing semantic search, how do we chunk it up? How do we do the search over the documents? Is the relevance good there? Once we get the documents, how are we presenting it to the model? Could a human, I like empathy here, could a human understand the way you present these things to a model? And then once the model has the information, is it actually generating a good result, or does it need like coaching to change its behavior slightly? So if you think about this as being a very transparent box instead of RAG, then you have a lot of places that you can, in diagnose and insert changes and actually improve the situation. So they are related technologies. They go really well hand in hand. But I do think it's important to keep a distinction between what is retrieval and what is generation.
Makes sense. So let's go more into the loop that you mentioned earlier, and you talk about in the book about this loop for taking a user problem, converting it into a prompt, and then being able to process that response. Let's talk a little bit more about what that loop entails.
Well, so effectively, me and Albert's understanding of the loop came out of our initial work with Copilot in these completions, and it was a very different world at the time. So some of the things that we've said we've learned a broader understanding than we even presented in the book, really. But effectively, in the world we have today, or the world the much more constrained 2,000 token context that we started with these completion models in the book, the steps are going to be basically the same. If you're trying to transition from the user's understanding of the problem space to the model's understanding of the problem space, which is text and content like that, then the first step you do is retrieve the context. So our exercise in the book here is just lay out in front of you, maybe even do like the yellow post-it notes, write every possible thing that might be of benefit for considering the answer to this problem. Think through it as if you're instructing a junior coworker. Like, how would you solve the problem? Because these things are ultimately going to be like, you can sort of treat them sort of like humans, right? So gather all the possible things that you can use for content, for the content. Put that out. Put that aside. Think about next is how you snippet them. So just because you're doing an IT support chatbot, you've got to actually take all these documents and figure out how to chop them up into something that's useful. If you're doing lexical search, then this is pretty easy process. You just say, here's all the docs. But a lot of times you have to do like snippetization and figure out, instead of just here's the doc, what are the pieces of the document that are most useful to get out? You can think about how to chunk them, or even once you get chunks back, you might want to figure out exactly the shape and the size of these fragments that you're getting ready to stick in the model. Okay, so now you got on hand a bunch of little snippets that are useful for various different reasons for solving this problem. So you think about scoring and prioritization. Now, this is one thing that has changed in nature since we wrote the book, since we started writing these sections of the book. With Copilot, we have 2,000 tokens. And if you go over that, you just get a hard error. These days, most of the models are like hundreds of thousands of tokens or millions of tokens, even some of them. So almost these hard limits that had concerned us are not really a concern anymore. But you still have a concern as far as latency for your user. You have a concern as far as the amount of money you're going to be, handing over to the model provider. So you still have to be concerned about how much information you're packing into these things. So scoring and prioritization, figure out which pieces of these snippets you absolutely have to have. And with Copilot, that was putting things on, and I could tell you about the Copilot algorithm if you'd like that in a little bit, but it was putting it on several tiers. Like the most important tier is the document. Next to most important tier was like neighboring documents, little snippets from that. But you can also use scoring of something that's more fluid, like this is a boost, and so it's more like lexical search or something. Okay, finally, now we've got a bunch of snippets. We know the rough size that we know what order that we want to take them in according to priority. That might not be the order that they actually sort in the final prompt, but now's the time to do that. So the prompt assembly is taking these snippets, choosing the highest to lowest priority, assembling that into the boilerplate of the prompt, and then shipping that off to the model. Completion comes back, and that's when you finish the other side of the loop, extracting that data and presenting it to the user however they expect it.
And as you actually put all of this together and then send it to the LLM, it's in like a markup format, right? So everything that we're talking about here, you're doing programmatically, and then you're kind of constructing it in a markup format for the model. Is that correct? And that's how you process a response, also. How do you
Very typically,
interpret it?
yes,
Yeah.
but I'll generalize over that statement. One of the things that we really tried to drive home in the book is, again, the need to empathize with the model. And so you think about the model and you think about, well, what is it familiar with? Fortunately, it's read the internet 5 times or something like that. So is whenever you're conversing with the model, whenever you're trying to put something, at, here's a way to think about it. Here's a way to empathize with it. The original models and even the chat models, in which you really dig down deeper, are just completion models. They see the top half of a document, the prefix, and they're one token at a time predicting next word, next word, next word, next word. And so if you want it to have the best shot at making a sensible prediction, then you make sure that the top half of that document looks like something that it's familiar with, and then you can depend on it to do a pretty good job.
Mhm.
So a lot of the times when we were doing just completion models, that meant doing very common document types. Markdown is a super important one. But we're also doing, Copilot, we're also doing code. So, R, Python, anything like that, you could just have that document and the model would know how to complete it. Now, how that's changed with these chat models that are, absolutely dominant at this point is this document that the models have been trained on are now all transcripts. These documents, it's like you picked up the model effectively is picked up off the ground a something that says, "Hey, this is a script." It says at the top, "This is a script," and you're playing the role of this, character, super helpful assistant, and this other person is playing this role. And here's the conversation so far. How rather than treating it like a person and saying, "What do you think is next?" What these models are really doing is saying, statistically predict the next words. And so, even though the whole document is no longer marked down, it's important to still have kind of these motifs that the models have been trained on. The models have been trained to look at these scripts, and inside the scripts, they understand what markdown is. If you have a certain type of information that you want to present the model, don't introduce new terminology if it already exists. Find terminology that exists in finance or whatever. Don't introduce a new document type. Use a snippet of an SEC report, something that's seen bazillions of times, and you'll get a lot better completions out of the model when you treat it like that.
So even though you're still working with the chat API for certain use cases, you may still provide like an opening sample or a document format in order to, it's more like the way a completion API used to work in the past, but you still get some benefit from that. Am I understanding you correctly?
Anytime you keep the model into a space that it's seen, you're going to have better performance. Use common motifs. Anytime that you have to travel away from that, then you need to do a little bit more explanation. For example, one of the things that we worked at GitHub was some of our clients have programming languages that are kind of like bespoke programming languages. If it's just like a little bit different, like for instance, they're still using Python, but they've got kind of like a format that they like everything to be done in, then you can probably get away with an explanation. If it is more different, it's like a completely bespoke, DSL or something, then you might have to do some fine tuning and training to get that information into the model.
I want to take a moment to tell you about our sponsor, WebRTC Ventures. At WebRTC Ventures, our teams are experts in building live video into your web or mobile applications. We've literally built hundreds of them. We have over a decade of experience using both open source and commercial media servers in a wide range of industries, including telehealth, edtech, broadcasting, and more. We also publish a lot of helpful tips and industry interviews on our website and our YouTube channel. So be sure to check out webrtc.ventures and we can help you build, scale, and deploy your video solution. Okay, makes sense. You teased something a few minutes ago. I want to make sure I don't forget to come back to. You offered to tell us a little bit more about the Copilot algorithm.
Sure.
Tell us a little bit more about how that works.
I can tell you how it used to work. Of course, I've been away from Copilot, from GitHub for not quite a year yet. But a lot of this stuff was public anyways. The way it was public was an interesting side note in our history. We hadn't published any blog post about how our algorithm worked, but there was some very, very smart guy, and I used to know his name, that wrote a blog post. He had apparently like backward compiled VS Code and figured out all of our internal APIs and how we were like weighting different parts of the prompt together, and wrote a blog post about it. That was better documentation than what we had internally. It was just great. We weren't able to hire him, but we did try. Um, the algorithm is pretty simple. I'm sure they've made some changes since I've left, but it follows kind of the pattern we saw earlier: context retrieval, snippetization, scoring, and prompt assembly. And so, context retrieval, what is on the table to help us out? Well, obviously, you have the content of the file you're currently in. And these models were trained on only the content of the file. It's just like it just gets whatever's on the website. And so if you look at GitHub raw, that's probably roughly what they were completing from. They take half the document and do the other half. Okay, so you've got the whatever information is in the file. When you as a human are using your IDE, what do you usually do? You open up other windows that you can refer to and figure out information. And so my co-author actually is the one that had this realization. It's like, well, let's just do that. It's a great example of how you're trying to think through the eyes of these models as if it's a person trying to do this task. Okay, it can help you to have this other information about the files. Also, the training set didn't have the name of the file, the path of the file. That's a real simple one. It carries a lot of actual meaning. If this is a Django app, we know what this path usually implies. It helps quite a bit. And then we were constantly trying other little things. My favorite thing that I tried was using the language service protocol to say, if you're typing in this function, go get the function signature. And that way the model doesn't have to guess at it. It just has it there. And so that was all the context retrieval aspect. The next bit is snippetization. And so as just a small example of that, with the neighboring files, what we would do is just have a moving window. And we'd say, what is the similarity of the context right around your cursor that you're typing in right now? And this window, this window, this window, this window. We do that for all the open files, and it's super fast. And so we get the top 3 or 4 slices. Snippet scoring and prioritization. Basically, number one priority is whatever's right on the cursor. You get as much as you can up towards the top. If you have more room, you will have more room for the path. That's something that we absolutely had to include, because it's just so small but carried such juicy information. So that was super high priority too. That's like the second priority. Third priority is start pulling out snippets from the neighboring tabs, and then higher the priorities past that are reserved for like experiments and stuff that might be good. And then there's prompt assembly. And for completions, it's easy. You just put the document there. But you do kind of trick it out a little bit. You have the path at the top. That's an easy one. And then all these snippets that you pulled in from neighboring files, if you just plopped them in, then think like a user. If you just plopped them in and said, continue the file like you see above, then it's kind of garbage. It's all mangled. It's like, I see a mangled Python file, so I'm going to contribute to this by creating a further mangled Python file. And we noticed stuff like this. You'd actually, like, if you misspelled comments, it would generate crappy code based on your, intelligibility.
That's what you want.
Yeah, I'll just do what you say. We're making crappy code today. Yeah, so what we did for the snippets to prevent that problem is we would present the neighboring snippets in a comment block with the comment markers appropriate for that language. So it'd be different for whatever language. And then you'd say where you got the snippet from, and I think this might be useful with the code below. It is as if someone was writing the code and had collected all the pieces of code. You kind of created a situation where this is now actually a valid piece of code. It's just not the actual code that the human was sitting on their desk working with. So it's a neat trick that we used, and it worked pretty well. I think technology is moving a lot. Cursor has been doing some really amazing things. I'm pretty sure that they don't use a completion model anymore. I'm not sure anyone uses a completion model anymore. And the technology keeps moving. So I'm very interested to keep an eye on this space and see kind of what Copilot and competitors are doing to solve the same basic problems.
Yeah, absolutely. Very cool. Thank you for sharing that. And I love the example of looking at other tabs that the developer has open as an example of the type of context that's very unique to that use case, right? Every use case, every application that you're building around an LLM probably has some sort of unique twist on what context means in
Yep.
that sort of scenario. I mean, it kind of, it's a little bit like if you were building around an e-commerce application, looking at what are the other products you've searched for, or, pulling in context of how you rated products that you purchased in the past and what you liked and didn't like about them. All sorts of interesting things you can pull in there unique to your use case. Now, so you were saying, in the past you had more of a token limit than you do now, and so context retrieval and how you segment that and how you prioritize it is really important. That's maybe less of a concern now, though cost is still certainly a driving factor for sure. But how do you decide like how much is too much in in giving the model if you're trying to strike a balance there? Is how do you decide, okay, this is this additional 20% in cost in tokens that I'm sending is not really giving me 20% more value, let's say.
Sure. And the easy answer for that is metrics and evaluations. Now, the hard answer to that is metrics and evaluations are very dependent on whatever project you're working on.
Mhm.
But what I would do is figure out what is most important to your customers. I would we could get into evaluations a little bit if you'd like. I would set up some offline tests to as you're making these changes, have some synthetic tests that really closely approximate what's going to happen in the production test, and make sure that ideally things keep going up, so you have an idea that it's going to keep improving. And then once you actually and I guess off, like, you can also do things like you look at latency, you can look at the expected cost. Might not be quite the same population as in production, so you have to make sure you're got your metrics in production to make sure it was realistic. Yeah, but then it becomes just kind of um, keeping an eye on the metrics, making sure that they go up enough to justify the incremental cost that you're spending. For GitHub, that is looking at how often these completions are being accepted, and how often the number of tokens that are a number of characters that are retained. For your own project, it's going to be something completely different. Um, and it is, maybe to step back a little bit, it is completely expected that if you add more and more stuff, you're not only going to saturate, it's going to keep increasing in cost, but the amount of benefit that you provide is going to plateau. These models are doing better and better for more context, but they're just empathy again. They're quite a bit like humans. You give it so much stuff, and they end up having more and more trouble picking out the important stuff, because you said, blah, here's everything that might be useful, solve this problem, I'm going to lunch. So crafting a good context is important for getting the most out of these models efficiently, low latency, and low cost.
And so I guess that really highlights one of the important themes here is that yes, tools like Copilot are amazing. The many different ways that we can use LLMs to improve efficiency, speed, quality are amazing. But garbage in, garbage out, right? The principle still applies. And so the value of a software developer, of the technical team working around that application, doing the prompt engineering, is still very much a human skill, right? And something that you can develop as a team. And as an individual, so yeah, you're not just going to feed in a course syllabus and have it teach your class and take care of everything for you, right? There's
Yeah,
still
absolutely.
a lot of human element that's important in this. So you touched a little bit on testing, and I guess because in most use cases, maybe all use cases, the output of the LLM is not going to be repeatable. Um, the output that it gives you is not repeatable. So I guess, are you always just testing kind of in the aggregate based on like metrics across an aggregate, rather than, saying I got back this response repeatedly and I don't like it?
Um, well, let's dig into all of that. I'll take a tangent at first because you kind of touched it a little bit. There is rare cases where you probably can get deterministic answers out of these models. I was doing this yesterday. Um, the models generate tokens stochastically, so it from one generation to the next, it will be different. But in really rare situations that you don't see in production that much, but it is a nice tool to have in your belt. The tokens are stochastic, but the log probs, the probabilities of the tokens, are not stochastic. And so one kind of interesting thing you can do is create classification algorithms. And you just say, like, for example, a simple case, you could say, blah, 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 is this true or false? Answer only with a word. And then you can look at the log probs of the next token, and it will either be TRUE with some sort of log probability, or it'll be FALSE with some sort of log probability. And it'll be the exact same every time. That's not stochastic. That distribution is the same. So occasionally, you can do interesting things like look at the log probs and uses like a classification algorithm. Complete tangent. Don't do that. That's crazy. But when it comes to actually evaluating these things, that's the real question. Again, I lean on my experience at GitHub for we really had an ideal situation at GitHub, and often you just don't have this. But with code, it's interesting because the code that you generate, either it works or it doesn't work.
Right.
So you can do really interesting offline tests that are really high fidelity. The cool thing that we were doing is basically like human eval, right? We were taking repos that are in the public domain. We were looking at the ones that had good tests. We were figuring out, which tests are associated with, which functions. And then offline, we'd say, all right, take this function, gut it, generate the middle, run it again. Does it pass the same test? And then in aggregate, this you have to do in aggregate because it's very different from one generation to the next. We can say, how often did this test of this function pass, and then look at different languages and look at, everything else. And that's an ideal situation if you can do it. Have offline evaluations. You can experiment on stuff like that before ever putting anything in front of your customers, and you can get a really good idea about which direction things are going to head once you get it into real traffic. Real traffic's always different, though. In practice, it's very rare to have such a clean use case, a clean framework as that. And so you might find yourself doing something that's more hand wavy. So evaluations usually start off as like, I'm hearing a mic somewhere. Okay.
No, you're good.
Evaluations start off is vibe test always, and they should. People disdain a vibe test, but no, get to know your model, get to know your problem space. Write out something that you think is realistic. Generate synthetic data. Figure out how to make the models actually generate synthetic data, and run 20 realistic examples through. Look at the outputs. Ideally, you have some deterministic way of testing it, like we did for Copilot. Probably you don't. So as things get more mature, you move on from having just yourself looking at the outputs to having, if you're a little bit lucky, having a small team that keeps their eye on how these outputs look and make sure grade them. As they mature and as the whole system matures, then hopefully you can get into things that are more automated. Large language models as judges, that's kind of like a whole domain. We're still trying to wrap our heads around this. They don't always, who's judging the judges? They don't always do a great job. But there are good rules of thumb about how to get the best judgments. and you tune your judge model so that it will most closely agree with your human judges, and then eventually you reduce the workload on humans entirely and have something like that. But as like Hamel Hussein often says, it's the most important thing is not the cool toys, the large language model as a judge. The most important thing is that a human is actually looking at the data and making the human judgment. We're still important.
Yeah, yeah,
Um,
that's good news.
to tie it off for evaluations, the final bit is online. You've got to make sure that online you're doing something analogous to what hopefully you can do offline, because the traffic online is always going to be very different than offline. It's offline it's synthetic data. It's just kind of a play version. Online you can do A/B tests against real humans and figure out, does this really make an impact, and that's where your final ship decisions should probably come from.
Nice. So you mentioned the possibility of LLMs judging LLMs, essentially, which I think perhaps is a good segue to something very much in the news now as we're recording this, and I'm sure still will be when this episode is published. DeepSeek, kind of the hottest LLM to be discussed right now, and with quite a bit of controversy also around it. It definitely caught the world's attention in the last week. There's a lot of geopolitical concerns around it, which are many. But even beyond that, there's a lot of hype around how it's built, how it's been trained, how it sort of judges its own answers, open source aspects, ability to run it locally, and then claims about dramatically lower costs. So a whole bunch of hype. What's your take on DeepSeek? What do you think so far?
Well, first things first. I'm watching the news just like you're watching the news, and I don't know all the details. So your opinion is probably as good as mine on this. But I think Sam Altman probably had a very bad day that day when it all came out. Effectively, and get ready for me to misquote everything I've heard on the news. You should probably fact check all this stuff. But DeepSeek R1 effectively does the same thing as like O1, except they're free about it. Like O1, the thing that I, as a prompt engineer, large language model application developer, thing I want to know is what it is doing during the thought process. Because if I know that, I can direct it, I can improve, the other applications I'm making. They hide that. That's frustrating to me. R1 is like, oh, okay, well, we're just not going to hide it. You can see whatever how it thinks. That's cool. Yeah. It undercut OpenAI drastically in the price that their services are charging to do this thought process. The quality is ostensibly just right up there, about as good. It's completely open source, so it took OpenAI's models. Like, yeah, well, here it is. They opened their kimono for them, and it's just and it's so cheap to train as well. That's kind of like the other thing. It's like is an order of magnitude cheaper to train. It's good. I like technology and information to be free. That's kind of the thing. I think overall it'll probably be good for everybody. But it's just like every other day in this field. Today is a new day. Everything is different from yesterday. It's like we'll see what happens. It's been interesting to watch.
Yeah, no doubt. Well, and I think that because every day is a new day, especially in this field. I think that's what stresses to me really the importance of this application layer that you talk about, and this loop, and how you interact with an LLM, right? Because I think one of the interesting observations I've seen from the discussion around DeepSeek is that if by making it lower cost and more open source, you have the opportunity for companies to kind of do a little lower cost training of their own, more ways that they can implement with this, which all means that the value of this is back in the application layer a bit. It's not just all the value of our future business systems and software and everything we look at on our phone is not all going to be captured entirely by OpenAI or whoever, right? It's
Yeah.
There's still a tremendous amount of value in the application layer, and taking your personal accounting application and how you work with LLMs from it, not necessarily the LLM behind it, is where all of the value is, right? It's how
Yeah.
you pull these
Absolutely.
together, and that really comes back to the whole concept of prompt engineering, and everything that you talk about in this book. So I really like that. That at least is a very positive, likely outcome of this from my perspective.
Yeah. I think
Um,
overall it's good.
yeah. So we're running out of time, but I can't leave out one other interesting sort of cutting edge topic around this that you also hinted at earlier: agentic AI.
Hmm.
So as you mentioned, the idea that we could not only just do kind of question and response with an LLM, prompt and response, but also maybe that system around it, I suppose more than the LLM itself, really,
Yep.
is able to go make changes in the real world, somewhat, at least autonomously. How
Yeah.
realistic is that? How far, how feasible is it now to build a truly autonomous LLM based application?
Hmm. I think everything is a spectrum. Everything in my head gets mapped to spectrums, and in this spectrum of agency, the thing that people are talking about is still just a bit sci-fi. We don't have AGI yet. We don't have. I don't have a machine that I would trust as much as I trust you to, like, go get me a burger and have this on it. I just, it wouldn't work out right.
Right.
Um, I so we're moving towards it, and so I'm not disregarding it as a possibility ever. But I think there are the best things that you can do with the technologies that we have right now. In our earlier conversation today, we talked about, like, how to do one lap of that loop,
Mhm.
but you can build more sophisticated mechanisms around the model, and make that loop more complicated. You can add RAG so that you're pulling in information from the outside. You can, rather than you know your application pulling in information from the outside, you can actually give tools to the model so that the tools can go and access other APIs and get stuff. The tools can even use the search itself. So the tools can be in charge of the RAG and have, what did Doug Turnbull call this? Generative. I'm not going to say it. He had something with GAR instead of RAG. Never mind. But but still, today's models get off track pretty easily. You have to have a human in the loop into today's technology. And as I kind of expressed in the book, there's two ways of getting that human in the loop. Uh, Two easy ways. One way is having a conversational agency, where basically you are working with an entity that has tools, can reach out into the world, has RAG, can do all that stuff. But every step of the way, you get observability into how that entity is working, and you get to modify stuff. The UI should be built up so that nothing dangerous takes place. It's you can slap its hands whenever you want to. The other way that humans are still in the loop is in what I'm calling workflow agency, which is, I don't trust you long enough to let you go off and absolutely do anything on your own, but you're building this widget. Here are the steps involved. Here's the information that you have to get. Here's the tools to how to get it. And if I can create a tight enough set of instructions for every one of those nodes, even if it could be like a tree. It could be like, okay, what output did you have? Let's go back to this decision loop. It's a flow chart. But if I can create something that the junior developer on the team understands, then the models at this point are getting good enough that that they can be depended upon to do pretty well with that. I think it's still little bit further before we get into like complete agency.
Yeah. So at least for now, that LLM based burger ordering application is going to need to show me the order confirmation screen before it hits place order on my delivery order there.
For
So
debits that credit card, yeah,
yeah, exactly.
human in the loop.
Exactly. Human in the loop. All right. Well, John, thank you for a fantastic conversation today. I really enjoyed it. Are there any closing thoughts that you want to share? And also, how can our listeners learn more about your work at Arcturus Labs and where they can pick up a copy of your book?
Yeah, absolutely. So I am John Berryman. I am Arcturus Labs, arcturus-labs.com. Arcturus is a navigational star. That's where the name came from. I'm also, look me up on Amazon. I've written a couple books. And I'm pretty easy to find. There's a place on the website that like a contact form. If you have any interesting problems that you're working on, I'd love to chat about it, to see what you're up to. If you have any problems that you're trying to struggle through, it helps me to think through your problems, and maybe I can help you out along the way. So yeah, please reach out. I'd love to hear from you.
Fantastic. Thank you so much, John, and thank you for being on the Scaling Tech podcast.
Yeah, thank you.
On behalf of the thousands of developers we've placed with our clients, I want to briefly tell you about our sponsor, Agility Feed. Agility Feed has been building nearshore agile teams for U.S. companies since 2010. We were an early pioneer in doing this sort of developer staffing. Our team can help you recruit talented software engineers and technical teams in Latin America. We'll handle all aspects of recruiting, contracting, and payments for you so you can focus on delivering great software. To learn more, check us out at agilityfeed.com. That's agilityfeat.com.